using it to go and review the videos to go review. Are you guys using it? So the live broadcast will stay till tomorrow morning. After that, I'm going to replace it with a cleaned out video, which will be available through the website. All right. And I should finally share the screen. Where am I? Week 1 quiz. All right, guys. So the first question, are you able to see my screen now? Is the font big enough? Any feedback, guys? Anybody?
Yes, sounds good.
So in machine learning, NLP stands for which of these? Obviously, it stands for natural language processing. I thought almost all of you got that right. So given a body of text T in a human spoken language X, in order to translate it to some other language Y, which of the following is true? So one of the things is, it used to be very hard actually to teach machines to do language translations. They were very, very poor at it. One of the big breakthroughs that have happened with the coming in of deep neural networks and support vector machines both, is that some of these things, as the more advanced algorithms came, these things became possible. Now, there's been quite a bit of theory, like people who did computational linguistics or language modeling, natural language processing without AI, they used to have all sorts of statistical models to do, to bring about something like that. But with the coming in of deep neural networks, it has been a game changer. The first neural network architectures that could do it were called the recurrent neural networks. And in that generation, you have the LSTMs, GRUs. But in the case of recently, actually, more recently, there has been the breakthrough of transformers. Transformers were discovered, or the paper on transformers came about in 2017, December. Since then, the last 3 years, 2018, 19, 20, 2.5 years, we have had a sea change in natural language processing. Today, we can do a whole lot of tasks with transformers and their variants or their combinations with RNNs and so forth that that have a far higher accuracy. You see this being talked about in the market. You see chatbots everywhere. Every company trying to incorporate it, knowledge summarization. If you have tickets, bugs in your system, how can you find duplicate bugs and so on and so forth. Lots and lots of people are busy doing that. And the efficacy of that is just astounding these days. These natural language processing, these transformers are able to even write code. So one of the questions that arises today is, the GPT-3, for example, is you can describe a UI in English, and it will translate it not to German or French, but it will translate it into a pretty good HTML and JavaScript that is bug-free. And that is quite amazing, isn't it? Soon they may be writing the code for us in a few years. So that's the scope of this. Today, translations can be imperfect. If you do translations, you see sometimes it can be hilarious. But at least by reading the translations, most often you get a sense of what was said in the original language. Go ahead, there's a question.
Asif, Ramki here. So you're talking a little bit about the complexity of data collection, just before lunch. So that's a big problem, right? I mean, like across geo-distributed data centers and data privacy, all those things. So I'm just wondering, does this DNN solve any of those problems, or it's still that onus on the data collection is still very much there? That problem is still very much there.
Two things have happened. It is called pre-processing. All the steps you do before you do the machine learning, the training of the machine learning model, is called pre-processing. Pre-processing has always been a very manual task. Programmers would do it. They would write, some of you may remember the world of ETL, extraction, transformation, and loading, the
Yeah.
world of things like that. And today we call it data extraction or data ingestion, and so all sorts of words, and data munging. So these are more or less synonymous, in a broad sense. There is a lot of data transformation. The reason is data will never come to you in the way you want it. You have to do a lot of traditional engineering to get the data into the format that you do. And that has not changed. What has happened, though, in recent terms is, and you will learn that is the crux of AI, that people used to do feature extraction. Like, what is the input features that will go into your model? The X vector. One of the remarkable achievements of deep neural networks or deep learning is that it does something called representation learning, which means that you don't have to do feature extraction. Once you have vectorized the data, then it can automatically discover the relevant features. That is one of the most amazing discoveries. In fact, that is what brought back the neural networks back to life. In 2006, the great breakthrough that Geoffrey Hinton made was with representation learning and so forth. And deep learning became a big thing again. In fact, it became a big thing. The word, when we say deep learning, we refer to deep neural networks, and it is fairly reasonable to say that a good starting point would be Geoffrey Hinton's work in 2006. So we have moved the needle a little bit back. Now representation learning is there. But can you take care of the ETL jobs and so on and so forth on its own? Once again, there is some progress. See, in business, there are common entities. There'll be a user. There'll be user can be the buyer or a person in, employee of a company, whatever it is. And when you store it in databases, especially of the relational kind or in Mongo or whatever it is, people tend to give very common attribute names, Mongo document field or relational databases column, tables columns. They will have things like first name, last name, and this and that. One of the things that people have done and are doing now is they're using deep neural networks to inspect the data and infer what is it? What is this column? What is this attribute? By looking at the data and inferring it, by looking at the values and inferring it, so that it is not completely automated, but there's a lot of effort to cut down on that pre-processing task. And there's significant progress. I would say that, see, much of the ETL and other things, they will certainly get accelerated. I don't think
Sorry,
they'll.
Asif, your voice completely broke out for last almost 15, 20 seconds. Would you mind?
Oh, it did.
Data ETL, yeah.
Okay. So what I'm saying is, with this AI techniques, people are applying it to inspecting data and discovering the usual suspects, the user entity, the user columns, the user fields, first name, last name, and so forth, and so on and so forth, items. So there is a consolidated effort to have AI permeate the world of ETL and so forth. And I would say, if I have to guess, see, ETL is a big manual problem. It takes a lot of effort to make. There's a reason why businesses like Informatica and others, they have such a huge following. They make tools to make it easy. Ultimately, you can do all the ETL in pure SQL. Informatica just simplifies the creation of the SQLs by a visual designer and things like that, and then runs a ETL server to do the transformations for you. So in that space, AI is entering by just accelerating the process, discovering the usual things and so forth. But at this moment, we are nowhere close to having it figure out from plain language what should be done with the data and doing it. Though there is a lot of research that's happening there, academic research, we are still a little bit far from that.
But just like mapping out to, like you said, in the automated feature extraction, right? Would it be fair to say something like in distributed systems, for example, large-scale distributed database, there are tons of logs being generated, right? So many logs. You're trying to figure out root cause of any kind of problem, right? Security attacks.
RCA analysis, root cause analysis, AI is very effective. In fact, I could make it
would it be fair to say something like you don't need to worry about that? So basically, which fields to pick from the logs, but this deep learning would sort of auto extract it for you. Like don't worry, it'll
Yeah, there
figure
are
out.
many techniques. There are many, many techniques of AI that is people are applying to log analytics, and with fairly high degree of accuracy, they can pinpoint the root causes often, or at least point you in the right direction, narrow down the choices. So the applications are there. People are doing it. Creating frameworks to do it. I don't know how much of it is commercialized, but people are certainly writing papers and things like that on that.
Very interesting. Thanks. Yeah.
The next question, question 3. What is XAI? Of course, it stands for Explainable AI. It was just a terminology stuff. Um, so we covered that. The fourth one is transfer learning is what it is. Taking a model that has been trained on one task and using one set of data and then applying it to another related task, of course. Like we did it. We did ImageNet was an example of transfer learning, right? We just transferred the problem to our stuff. And sometimes you can't just use the model as is. You have to train the last few layers, that is called fine tuning. And we learn to do that. So auto ML is what? So this is a question I hear a lot from business. You talk about automated machine learning and the first thing they'll say, oh, Google auto ML. No, it is not. Google has nicely captured the buzzword auto ML as the name of one of their services, cloud services, but no, automated machine learning is the subject of creating machine learning algorithms that tune themselves for best performance, right? The best architecture and so forth. Now, CFAR 10 classifier was the lab class that I gave you guys. I hope, did you guys get a chance to play with it?
A little bit, Asif.
Yes,
Didn't
guys,
really.
you have to do the lab. If you don't do the lab, you'll never gain confidence. See, both theory and labs are important. Please do the labs carefully. Later on, review it and make, because we'll move forward and do a lot of code here in this workshop, practical code. So, all right. So the CIFAR, one of the homework that I had given in CIFAR was see if the error rate decreases with the number of epochs. It does, right? And the other is if you change the learning rate, it affects the efficacy of it. You can screw up the accuracy of your model by taking too big a learning rate. Now, those were the things meant for you to discover by doing the home lab works. So do the homework, guys. Do the homework, please. Question number 7, which of these topics are considered a part of automated machine learning? The answer to that is, neural architecture search is the one I think you missed. But other than that, neural architecture search, hyperparameter optimization, and meta learning. We talked about these in our lecture. Then XAI stands for extremely large AI models. No, it does not. Obviously, this question, almost all of you would have gotten right if you have been attending the lectures. The next is Inception V3 is one of the pre-trained models available that can be used for image classification. Well, we did it in the lab, on the Wednesday lab. And if you did the homework, of course, you must have seen in the lab, we saw that Inception was one of the models. In fact, it was the one giving the highest accuracy for the examples that we took. So it is one of the pre-trained models available. We did that in the class. Question number 10, which of the following are some of the publicly available pre-trained models available for tasks such as image classification? So the answer is, obviously I threw a lot of things. I don't know if DilbertNet exists. I don't think so. Then AliceNet is also just a spin on AlexNet, to confuse you. There is no such thing as AliceNet. There is no such thing as PythagorasNet. And ImageMagick is a Linux software to do image processing, not a neural net. So here, these two answers are correct, but AlexNet is missed out. Google Inception should be there. GoogleNet and Inception both should be there. So 3 of them are missed out. The correct answer is AlexNet, GoogleNet, ResNet, Inception, VGG. One of you are asking a question. Did I hear a question? No. All right, I'll move forward. Given a body of text, we can apply statistical and AI techniques to estimate the overall readability of the text by humans. This was a lab. I hope all of you got it right. We literally did it in the class. Yes, you can. Deep neural networks represent the state of the art in machine learning. As such, they supersede and always outperform all other classic models in this space. This is actually a very popular misconception. Deep learning uh, wipes the slate clean. It's the only thing that matters. All we have to do is do deep learning. Deep learning is the cutting edge for sure, but it isn't the only cutting edge. There are many areas of research. Not only that, there is such a thing as a no free lunch theorem. Those of you who did ML 200 with me would remember that I emphasized the no free lunch theorem quite a bit. No free lunch theorem is one of the most profound results, not just for AI in machine learning, but to the theory of human knowledge. What it says is that no one model will, on average, outperform another model. So every model has its place under the sun. There are certain data sets for which one model will do better than the other model. So that is a point. In particular, for smaller data sets, actually neural networks tend to do pretty badly quite often. So remember that. And one easy way to check this is to go to Kaggle and see for the various competitions which model won, which algorithm won. You'll realize that deep neural network doesn't always win. And deep neural networks perform inherently complex nonlinear transformations of the input to generate the predictions. As such, it is a fool's errand to try to explain their behavior or predictions. All we can expect to do is train them to high accuracy. I hope if you attended our sessions last week, you would realize that this is certainly not true. We expect AI is our black box model, but what we are doing is putting in every effort to make them explainable, right? Impose interpretations and explanations for them. So black box models are a dangerous thing. And one of the realizations recently has been how catastrophic their impact can be on civilization if they are not carefully understood and their biases surfaced. Therefore, there is considerable effort to have explainable AI. There is a growing collection of powerful techniques that help understand a neural network's behavior. The correct answer is false. I believe we are at the end now. Transfer learning means taking a model trained on one set of machines and running it on another set of machines for a given data set. I hope you all realize that is certainly false. Transfer learning is taking a pre-trained model for one task and applying it to another task. Related task. When a model learns from training data, all its hyperparameters get trained. I take optimal values for the task at hand. Why is this false? Because it is the parameters of the model that get trained, not the hyperparameters. Hyperparameters by definition are the God-givens to the model. It never tries to tune that. And that finishes this quiz, guys. So any questions before we stop here? This one was an easy one, isn't it? The first quiz. I'll stop the recording here. And
Sanjit?
go ahead. So if there are no questions, this is the end of our quiz, guys. Now, how many of you raise your hand? I believe in Zoom there is a way to raise hands. Raise your hand if you want to stay for the Python session. Those of you who want to stay for the Python session, do raise your hand and I should be able to see it somewhere. Yeah, I see one hand raised. Jay, you have raised your hand. No one else. In Zoom, you can go raise your hand. So by all means, go raise your hand. I thought Premjit, you were interested.
Asif, I'm interested. Sorry, I don't know how to raise my hand.
Yeah, this raise hand.
Me too. Yeah. I just sent a text that I'm interested. Raise hand. Don't know.
So far, I have a few people. 1, 2, 3, 4, 5, 3, 4, maybe 4 people. So what I could do, should we take a small break and then come back for it?
Sounds good.
Or would you like to do it another day? We have had a long session today. Any suggestions? We can do it tomorrow, or we can do it in the evening, or we can just continue.
So one thought, Asif, is at least we can get some of the basic environment set up, I think maybe it's, some screw up is happening, something very basic. If you're missing out, if you can fix that, that'll be good.
No, that is the help session. That is the clinic session. That certainly will do. But I'm asking about a formal introduction to Python. Would you,
Oh.
because we have been talking, we have been here since 12. Would you guys rather take a break and do it in the evening or tomorrow, or would you rather that we continue with that? The clinic will come afterwards. So if you guys are more interested in the clinic, we can do the clinic now and we can push the tutorial either to evening or to tomorrow.
So Asif, let's take a 5 minutes break and come back and let's do the Python. It's okay.
Okay, that is
Asif, I leave it to you. If you're comfortable in terms of you've been doing most of the talking, right? So if you're comfortable continuing, I'm on for today for Python.
Okay, guys. So then let's take a 5-10 minutes break and regroup in exactly. It is 2:25 according to my computer. Should we regroup at 2:35 in 10 minutes?
Okay.
Sounds good.
All right, guys. So we'll take it up then. All right, guys, are you all here? We wanted to start at 2:35. It is 2:35. So let's hope that people who were interested in the Python are all here.
Yeah,
Okay.
I'm here, Asif.
Wonderful.
Yes, Asif.
So go ahead. Anyone has a question before we start? I'll start the recording also. Everything, the YouTube streaming is still on. I'll start the recording and we'll take it from there. So you guys are on record now. Let me share. So, all right, guys, the best way to start with Python is as simple as that, just start. So we are going to start with this. And this notebook, again, I'll post to our portal. Should we say intro to Python? And we'll code along as we develop our ideas. Are you able to see my screen?
Yes.
Yes.
Okay. See,
So, Asif, one quick question. Today, as we're going through this, do you prefer that we actually start the same? Is there a Jupyter book that we should open and follow through, or you want us to look and follow through?
actually, yeah. So it would be great, actually, if you, on your machine, also start a Jupyter notebook. Do that.
Okay.
Do that. I'll go slow enough and I'll be explaining enough that if you create your own notebook, then you'll benefit more. Otherwise, we are all busy professionals. You won't get time. So guys, we get started. Have you all started a notebook?
I have many open.
Many open, good. So I assume that at this moment you have started. So guys, as you write your code in Jupyter, and I would suggest in the beginning, start with Jupyter and then graduate to, once you become a little bit familiar, I want to get you started with PyTorch, not PyTorch, sorry, PyCharm or Eclipse PyDev. Both of these are full-fledged IDEs and they make your life a lot easier when it comes to writing code.
So one quick question there, Asif. So when we install Anaconda, it comes by default, it comes with Spider, right?
Yes, Spider is there and Jupyter, Jupyter Lab, all of these are there. You can use Spider. See, here's the thing. If you look at the mind share in this community, in the AI community, it is broadly divided between writing all the notebooks and experimentations in Jupyter, Jupyter Notebook or Jupyter Lab, or Colab. Google's Colab is essentially the same thing. And writing longer sections of code in PyCharm.
PyCharm, okay.
Right. PyCharm is by far the leading. After that comes all the rest of them, Eclipse PyDev, and then the Visual Studio Code, and so on and so forth. Now, people who love Java and Eclipse, they actually find it easier to just add the Python plugin to their already existing Eclipse environment and start coding. But then Eclipse has a longer learning curve. If you're already familiar with Eclipse, then you are at a great place. If not, PyCharm has very little learning curve. Quickly, you can get started. And I'll do a session on PyCharm also. Let's keep it for next week, weekend. I'll do a session in which I'll walk you guys through using PyCharm.
Okay.
All right, guys. So in any programming language, if you think about it, these languages, if you are thinking from first principles, what you had is you need a place in so-called memory of a computer, random access memory of a computer, to store a value. Because let us say that you try to do X plus Y. You want the machine to compute 1,197 plus some other large number, Y, P, 2,003,000 something. And you can't do it by hand, you want the computer to do it. A computer is essentially made up of three things, like four things actually, roughly speaking, in a simplified way. And maybe I should draw this out because that I find that in a way it makes it easier to get a handle on Python quickly. I'll share a different screen, guys. Wait a moment. Are you guys seeing my writing screen? Are you guys able to see my writing screen? Okay. Yeah. So what we will do is we will use this. So let me give it a title, Python. So even before we do Python, I just want to set a perspective straight. And most of us know this, but we tend to forget. A computer has just three large units. You have the CPU, which can do arithmetic. It can do, hang on guys, I may have forgotten to stop. I'm getting an echo back. Why am I hearing my own echo? Are you guys also hearing a sound in the background?
Yeah.
Yes. I think all of us go on mute, you shouldn't.
Yes, if you guys can please, all of you mute yourself. Then, yeah, everybody seems to be on mute now. All right, so with luck, we won't hear that. Arithmetic and logic. Logic is and or operations, or nor, not, nor, etc. And these are logical operations. So for example, if it is raining and if it is daytime, then I may not go to Starbucks. That would be an example of a logical thing. Arithmetic would be 3 plus 7. And it has some register. Then you have memory, and then there is storage. Let me just mark it as storage, which these days are either SSD or hard disk, HDD. Some form of hard disk storage, or it can be cloud storage. It can also be cloud, whatnot, different forms of storage. So when you think of a machine, don't think of it as this fancy semiconductor monsters. Think for a moment the old way when these machines came about. What used to happen is this memory used to be, or you would save something in memory or to do these things by literally have a solenoid with a core, right? Or with a solenoid is an electromagnet, soft electromagnetic material, and with electricity. And when you would charge it up, it would get charged, it would have north-south, and so forth. So you would say that it has a positive state, 1, otherwise it could have 0. And you could have a lot of these solenoids and things like that, little bits. And then you could do your arithmetic logic unit. In the early days, it used to be vacuum tube transistors, something like this. You would do that. So go back to the very basics. Think of these as very physical things, and it will make it easy for you to understand programming. So suppose you want to do something as simple as z is equal to x plus y, right? So let us say that x is equal to 17, y is equal to 34. And let's say that adding these two is not so easy, and you want to compute z, which is equal to x plus y. So we will do this basic algebra using machines. So what do you need to do? You need to take this 17 and put it somewhere. It needs to be in the memory. So in memory, what you would do is you would take a certain area, certain amount of space, certain number of these bits. Each of these are bits and solenoidal. You would reserve a few of these to store the value 17, right, in binary notation, whatever its binary notation is. So once you store it, what you say is, logically speaking, you have allocated yourself a box. Here is a box. And this box, you have put 17 inside that box, the value inside the box, right? This is the value. And this box has a name. You want to give it a name. Let's say that this is like very much like your mailbox, a parcel. When you send a parcel by the postal service, what do? You put some stamps here and you put an address. You put a name to that. You say it is going to my friend X. This is X. Or when you do packaging, when you pack your house up or you pack some things, you put things in a box and you label the box. So X is the label or name. So what you do is you say that I will take 17, put it in a box, and then give it a name. Right? That is what it means to say in programming. When you say X is 17, you say that you have taken the number 17, found a box appropriate for it, put it in the box, and the name of the box is X. Right? So this is the real meaning. But when we say the people have created a bit of a jargon, they say the word, it's a variable. And the reason they say variable is it is possible for you to take 17 out of the box and put something entirely different in that box. So the box will still be labeled X, but some other value is sitting in there. And if you allow for the values to change, different things to be put in the box, it's a variable. If you don't allow it for it, if you put something and it remains that, it is a constant. So that is where the word variable and constant comes from, essentially. So whenever you read code, one simple suggestion is, whenever you read statements like this, you say is a statement, doing something. Always read it not left to right, which is a tendency to do as English-speaking people, but to read it right to left. When you read code from right to left, what you are saying is, think of this sentence, take 17 And this equal to has no meaning. It's just a symbol that people have used in programming. It sort of makes sense, but if you think what you're doing physically is you're taking 17, creating a box named X and putting 17 into the box. So let me write it in so many words. You take 17, yeah, create a box, label it X, and put 17 inside it. So this is what you should, what is logically there. You often say things like assign. The way people tend to say this statement is assign X the value 17. It's very cryptic because if you read it as an outsider, you say, what is X and 17? I can understand. What does it mean to assign a value? So this is what is meant when you say assign the value 17. Are we together, guys? Right? So far. So this is called an assignment operation. So now we do, going back to our fundamental problem, we are trying to do X plus Y is equal to 17. So what will you do? You will do the same thing. Y is equal to 34. So once again, we will think of it as taking 34, getting a box named Y, labeled Y, and putting 34 inside it. So suppose you do that, right? What will happen is you create X, you create Y, and then when you do Z is equal to this logical operation, these two things are copied literally as X and as Y in the so-called register of the computer. Computer has some extremely expensive, very small amount of memory built in. Those are the cache, L1, L2, L3 cache, and a registers. They're literally called the registers. Onto which all the operations are done. So you would load this data onto the registers, and then you would do the arithmetic logic operation. In this case, the arithmetic operation. So you add the two registers, and the accumulated result is 51. And now you need to store 51 somewhere. Once again, what you're saying is go create a box called Z, labeled Z, and inside it go store the value, because the moment you compute it in the register, you will need a place to store it. So go store it in a variable called 51. In a variable called Z, store the result of it. And computers move like that. All they do is, and if you think in terms of registers and arithmetic logic unit, you'll realize that all programming languages are fancy ways. They are nice ways to give you, or convenient ways to help you load things into registers and do arithmetic logic unit operations on them. Right? The one common operation that you do in every language is you get boxes and you put values in it. You assign them a variable, a label, right? And they are often called variables. In some languages like C, C++, you sort of distinguish between a variable and a constant in Fortran and so forth. In Python, you don't. Python is a much simpler language. When you say X is equal to 17, you take 17 and put it in a box. Now, there are two kinds of languages. One is called statically typed languages, and one is called dynamically typed language. There's a difference between the two. See, if you just have a general purpose box, every time you want to store something, you can give yourself a general purpose box. Think of it as just one of those, you went to Home Depot and you got some brown boxes for packing. Then you say that you're doing something called dynamic scripting, or those variables. In that box, you can store anything. You can store cookies, or you can store shoes. And it's terrible if after storing shoes, you want to store cookies, something like that, right? But nonetheless, you have the freedom to store whatever you want in the brown box. These languages are called dynamic languages, right? Or scripting languages and so forth. Python is like that. It puts no restriction once you have created a box named X. What you assign, when you say assign a value X, to assign a value to X, it means putting a value inside X. Now, what you put can be a number, It could be a shoe, it could be a string, it could be just about anything. That is something to remember. Now, if you're familiar with another kind of languages, for example, if you're familiar with, so R, by the way, is also in that category. But if you're familiar with a language like C++ and Java, in Java or C++, you can't do that. You have to be more particular. For statically typed language, let me move it here. For statically typed languages, so when you say X, you will have to say int X is equal to 17. This would be a syntax in C, C++, Java, right? And the Python syntax would be dynamic kind of language. That would be Python, R, or JavaScript, and so forth. You would just say X is equal to 17. Or the equal, see, this symbol is not really equal to, it's assignment symbol. And it differs from language to language. For example, in R, you would say like this. And it sort of makes the meaning in my mind much clearer, that you take 17 and you're assigning it or putting it inside a box named X. Right? Equal to might make you feel it is X is equal to, X is a box. It can't be equal to anything, but you can put a value inside it. Now, there are advantages and disadvantages between these two. What happens is when you use statically typed language, it is strict. It doesn't give you much flexibility. So the amount of code you write tends to be a bit longer. These languages are a bit low level. They are verbose. That's the downside. The upside is because you are declaring what the type of a box is, you can't make a mistake. You can never put a string or a shoe inside a box that's meant for a number. Are we together? So you cannot do this. X is this, and the next sentence you cannot do X is equal to a message. Or you cannot do X is equal to some shoe. So suppose you have some shoe lying around, you cannot do this. So the system will not let you do that. Are we together? But in dynamic languages, it is perfectly okay to be able to do this. Message X is equal to some shoe. You can put just about, this is okay in dynamic languages. Do you see the distinction, guys, between Python or between the dynamic languages, and Python is in that category, and a statically typed language? Are we clear, guys? Right. So now the advantages and disadvantages. First is that if you have X, you don't know its type in a dynamic language. It may have changed. You may have started out with something and it may have become something else. Something else may be there, right? So imagine not looking at a box, putting your hand inside it, expecting a cookie, and a stinking shoe comes out. You wouldn't want to put it in your mouth. And that, in a sense, is the danger of dynamic languages. Dynamic languages are very simple to write. The code is more compact. You can do sometimes very interesting things with it. So for example, you can say, I will take any kind of thing and do an operation and things like that. The statically typed languages don't usually allow that level of flexibility. And not only that, the compiler has no clue. If you do this, in a statically typed language, a compiler would come and say, compiler will put those cross marks. The compiler that translates your code into an executable will go and flag it out. It said, no, this code is not acceptable. It's not kosher. On the other hand, a compiler will be silent because there is no compilation in a dynamic language. It is just in time compilation or no compilation at all. Things are executed statement by statement as it is. right? So what happens is you discover if you make mistakes with types and so forth. So for example, suppose X has become a shoe and then you do Y, X plus Y, Z is equal to X plus Y. You realize that there is, and let's say that Y remains 34. Then you realize that Z, this computation cannot be done. How do you add a shoe to 34? So the thing is, you will have a failure at runtime. This is an important thing to remember about dynamic languages, especially a language like Python. So Python, people have a lot of frustration sometimes with the debugging or the code. They feel it works, it looks logically correct. And then when you run it, you know that it's a mistake. The way you avoid it, so how do you have the best of the fact that static languages, the compiler will step in and help you, right? Prevent you from making mistakes. But the code is verbose. In Python, the code is short, elegant, in some sense, very clear, very easy to pick up, which is why I said we will be productive with Python in the better part of an hour today. And so it's very expressive as a language. Scripting language is always very expressive. The downside is you lose the typing. With dynamic typing, there's no compiler that helps you overcome its limitations. So there are two ways to overcome this, two important ways that you should follow. Those important ways are: one, ways to write, say for good, Python. What you do, Python. What you do is, first is the very basic thing, add type hinting. People are realizing that, static languages, when they declared the types, it was good. You give type hinting, something called, it helps the compiler. It helps the tools find bugs. So you don't find bugs when you run the code and then you realize that it failed. You can find bugs by adding type hinting. What does that mean? Don't just say X is equal to 17. And by the way, the type hinting is a new thing that most people in Python don't use. If you look at my code, you will notice that I use type hinting quite heavily. It is a good thing. Unfortunately, most people don't use it. So be warned that you may encounter most code without type hinting. So what type hinting says is you can declare what it is. Int is equal to 17. Have you noticed this? If you have been reading through my code base, have you seen a syntax like this? You may, if you go back, look at the Python code, you'll see a syntax like this. So what happens is that, remember that Python is a dynamic language. You can still do X is equal to a message, something like this. What will happen is, if you run this code, it will still fail at runtime at this. There is no compilation. But if you are using a smart IDE, let's say you're using PyCharm or PyDev or any one of these IDEs, this IDEs do the job of a compiler in other statically typed language. They will immediately see that given that you have given the hint int, this should not be allowed. And they will put a warning or an error, depending upon how you have configured your IDE, telling you that you're making a mistake. Because you're declaring your intent that always you will store an integer in X. So this is called type hinting. Type hinting is a very good thing. Since you guys are picking up Python for the first time, I want you to start out on the right foot. Do use type hinting. It makes your code a little bit longer to write, but it's worth it. So sometimes, in a statement like this, you might not need type hinting, because when you assign 17 to X, it is implicit that X is an int, right? It's an integer. So here, using it at this place might be an overkill. But there are situations where the intention is not so clear. So use it judiciously. If in doubt, use it. If it is very obvious what the type is, then don't use it. My rule, whenever you're declaring functions, always use it. Right? So now we'll come to the second thing. We'll talk about functions, but before we talk about functions, and when you guys write code, especially in Jupyter, functions will come much later. So we will keep it perhaps for another session. I will talk about basic constructs. See, there is
Asif, one quick question. The type hinting, does it work on inside classes also everywhere, or
oh yes,
or is there any restrictions?
A good idea will heavily use your type hinting. It's one of the things, guys. Type hinting was not used a lot, but if you look at the formal, the world-class libraries being written in Python now, they use type hinting a lot.
So would it be fair to say it came around after Python 3, Asif, like 3.7 something? 3 plus or 2.7 didn't have it, right?
Yeah, since see, I don't think type hinting existed in Python 2 series. It only existed in Python 3 series. I think fairly confidently I can say that, but I might be wrong. Huh? Any one of you who has more knowledge on that can tell me.
That's what it's. I mean, at least I never heard in 2.2 series, but I don't know about 3 much. So that's why. Yeah.
Yes, I mean, you should use Python 3. There's absolutely no reason to use Python 2 unless you're maintaining code.
No, but actually, this is a very good one you pointed out. Yeah, thanks. I think it's a very important one, actually, that I'm using the type hinting in Python.
Yeah. So, guys, stepping back, when you look at a programming language, believe it or not, there are only 3 constructs you need to make a language something called a Turing complete. As you know, Turing, of the Alan Turing fame, the guy who pretty much gave us computer science in the first computer. So one of his results was, but then later on for structured languages, we can state it differently. It says that for a structured language to be able to do everything that any any computer can do, that in other words, a Turing machine can do. A Turing machine is a general purpose hypothetical computer that in principle can solve every solvable problem, right? So to say, to be able to give instructions to a Turing machine, the language has to be expressive enough to have only 3 basic ingredients. Those 3 basic ingredients are, can you guess? One of them is statement. You know, what we just use, assignments and things like that. These are statements, right? You have to have the ability to write statements. So let me put these things. For a language, for a structured language to be complete in the Turing sense, complete, it just needs statements, conditionals, and iteration. So statement is an example of statement is x is equal to 17 is a statement. It's an assignment statement, right? Or it could be y is equal to the value of some function fx. Right? Those are all statements. What is a conditional? So a conditional would be a statement like, if it is raining, go out with an umbrella, right? Or more prosaically, if it is daytime, if day time, temperature is likely to be is equal to, on average, let us say 70 degrees, else temperature is equal to, well, at night, I suppose, temperature is much more likely to be 60 degrees. I suppose this fairly well describes the average behavior in the Bay Area, isn't it? So that is assigning the value, temperature, assigning a value of 70 to temperature if it is daytime, or 60 to temperature if it is nighttime. Do you see that? So it is a branching, conditionals or branching. So in a flow diagram, it would be like you based on this, you go this way or that way. Making sense so far, guys? And the third thing you need is the ability to iterate, repeat. In other words, you can say for 10 times, do something. This is an example of iteration. Or while some condition is true, do something. The hope is you gradually make that, you have something, you budge something so that eventually that condition will become false. Otherwise, this loop or this iteration will go on forever. So guys, branching, loop, and statements. These three are the pillars of a structured language. Any language that has only these three things is actually Turing complete. It can do everything that any other language can do. Right? So let us take some examples and think about it. When you just write HTML, do you think it is Turing complete or it is a complete language? Anybody?
No.
And why is it not?
I see it as a markup language. There are no concepts of
For loops, exactly.
conditional blocks.
Yes, it has statements, but it has no conditionals and no for loops, no iterations. Right. Let us look at SQL. Most of you have done played with databases. A SQL query or a SQL statement, SQL, what does it have? It has statements, right? What about conditionals? Does SQL support if?
No, it supports where.
Yes, it supports where, yes, which is the same as if. Yeah. And what about iteration?
No.
It doesn't directly support it unless you are doing some enhanced version of SQL, like for example, a PL SQL or something like that. Then our stored procedures, then it becomes, but otherwise you don't. So it is, in other words, a data manipulation language and a data description language, but you don't traditionally think of it as a programming language unless you add these extra things. But the moment you add these little extra things, it immediately becomes a full-fledged programming language. So every database vendor has done that. So you look at SQL Server, Microsoft's, they will give you their own enhancements. So you can write stored procedures using that. If you are doing Oracle, you use PL SQL and so forth. So all of these things give you some way to enhance it and make it a full programming language. Now, the reason I brought up this theoretical thing here is that two reasons. First is people often think it's a very simple language. I don't think it can do this or do that. No, Python has all three basics. Therefore, it can do everything that any other language can do. Right? The other way also sometimes people say Python is a modern language that does everything better than some other language. Right? That too is not true. Python, by the way, is not a modern language. It arose in the early 1990s. It's almost now 30 years old. So by no means modern, but it certainly got a lot of very popular these days. Python and Java are the leading languages at this particular moment. Dominant share, it belongs to them. Both of these, Java is statically typed, Python is dynamically typed. JavaScript is rising and probably about to gain as much. So the territory will be shared by three major languages, and other languages are climbing up the popularity ladder. So remember that when you pick a language, you're not picking a language based on whether it's more powerful. You're picking a language based on whether it is more appropriate to your work. So what happens is people who do operating system work, they have written the basic constructs for operating systems, like the locks, the semaphores, the schedulers, and so on and so forth, in C language, which is why you tend to see a lot of the operating system and systems code written in C, because libraries exist that make it very easy for you to do that sort of deep multi-threaded code at a low level. Right? So that is the reason you prefer C. One reason that you prefer anything else, for example, a lot of the middle tier code is often written in Java because there are tons of libraries. There is a ginormous ecosystem of Java libraries, so that anything you want to do today is just gluing these libraries together, and you can build an application in no time. Coming to Python and R and Julia, which is an emerging language. These three languages, they have made it a mission to focus. I mean, Python is a general purpose language, by the way. Even when you install Linux, your installer is written in Python and so on and so forth. Lots of Python scripts. But for data science, these three languages have become the favored language. The oldest of them is R. R derives from S. S is one of the most well thought out languages. In fact, it was given a very prestigious prize on the beauty and power of languages. I forget what it was, from Bell Labs. It's a very elegant language. Any code, I mean, traditional, a lot of the work, if you have been doing data science or machine learning, you'll realize that if you can do it with R, you will do it in far fewer lines than any other language. Right? It will just be one-liner, two-liners, and so forth. And very rich ecosystem of libraries. But then gradually, people, as data science, AI became more popular, machine learning became more popular, more people wanted to learn it. And a large number of students these days come with background in general purpose languages like Python and Java. So there was a thrust to create libraries in these languages rather than have people learn a new language. So a lot of the libraries were rewritten or recreated in Python. And underneath that, see, all of these behind all of these are the same old Fortran libraries, but nobody feels like learning Fortran these days, unless if you're in scientific computing. So over the Fortran and over the C, these are layers. R and Python, they just form layers over it in some sense when it comes to data science, machine learning. So Python became popular and a lot of libraries were created in Python. The process is still going on for much of the outside deep neural networks. Generally, R is richer, and the code is more elegant than with Python. But R again has a learning curve, and people don't want a learning curve. They say, we know Python to do everything else. Why can't we use Python for this purpose also? So the Python libraries are more or less catching up. For deep neural networks, it is Python first philosophy. The code, all the deep learning libraries, PyTorch and TensorFlow, the dominant libraries, they're all written in C and C++. Because those are high performance libraries. Nothing beats the performance, generally speaking, of Fortran. Then comes C and then comes C++. And then people are trying to create new languages these days, Go language and so on and so forth. And they're trying to have similar speeds. But I mean, the big king of the hill have always been Fortran, C, C++. Java is very fast, is beginning to catch up. For the non-UI stuff, is beginning to catch up with C++ gradually. Python, on the other hand, is notoriously slow. It's a horrendously slow language. Why? It's an interpreted language. You have to use all sorts of hacks to make it fast. For example, you have to pre-compile it. You have to use just-in-time compiler. You have to translate it into C and then compile and so forth. So those limitations remain with a interpreted language like Python. Like, it can be hundreds or thousands of times slower than C or C++. And Fortran is, of course, incomparably slow. Nothing comes close to Fortran. So that, but we tend to write these deep learning libraries in C++, and the first bindings we create, we tend to do it in Python. Second comes R. So this has been the state of the art for a long time. Then has entered a third language, a really interesting concept. It said that, see, why are we writing the code fundamentally in C, C++ because it's faster there, or Fortran because it's faster there, and then converting and then putting a layer of either R or Python on top of it? What if we created a language which was sort of like having the cake and eating it too? So there is a language on the block called Julia, new language. with a much smaller ecosystem. It will take a few years to mature, but it's quite elegant. And it's actually one of the things that I absolutely love about Python, about Julia, is that if I want to write theta, I don't have to create a variable called theta in English. Theta is equal to this. I can literally in code embed the theta symbol, the Greek symbols. And I just find that absolutely, I suppose little features like that make us like languages. I absolutely like Julia for that. It's just amazing. Right? So Julia is a language that tries to be very expressive like R and Python, but at the same time have native performance of C. And it has pretty much achieved that, but it's a young language, it's growing, smaller ecosystem. Where you can use Julia, you do use it. Where you can't, well, of course. So anyway, coming to Python, remember this, that Python is just, when we use Python libraries, the reason we do it is because people have committed time and resources to making sure that for all the common tasks in AI, we do have libraries in Python, and you can write it in very few lines of code. Similarly,
I think a quick question. So basically there is, you may know about this language Rust, right? It's pretty, I mean, it has won popularity, especially for memory safety and all those. Was it ever considered like sort of, something around when Julia came into play, like something like Rust or equivalent, or?
Rust and those guys, Rust is a great language. I like that. Though I must say that I look at it as an outsider, played with it, but never gone deep into it. It's not my cup of tea because I've been pretty much focused on AI the last few years, many years now. Rust is a good systems language. A lot of people are totally in love with Rust. The jury is out there. I think a lot of code is being written, new code is being written in Rust and Go languages. Right? A good thing. But in data science, their penetration is very low as of this moment. Data science AI is dominated by R, Python, and Julia in that order.
But Julia, what you're saying is placed like basically one language cuts across the layers from high level to low level. That's sort of the advantage of Julia.
Absolutely, that's what it does.
Very interesting. Yeah, I have to look at it. Yeah, because Rust I'm quite familiar. That's why I was wondering, is it like Rust or something which cuts across layers is not an easy problem to solve?
Yeah.
Yeah.
And guys, I have given a few sessions in Julia. If any one of you are interested in learning Julia, by all means, discuss it in Slack. If sufficiently many of you are interested, I'll be happy to give another free day of Julia session, a free session on Julia for half a day. It's a lovely language. Right? So, but the ecosystem is very small at this moment. Now, coming back to Python, what we are going to do, therefore, is we are going to learn. So knowing that the power of a language comes from the library, what do we need to learn? Why did I go into this digression? The reason I went into this digression is to say that you don't have to learn the whole Python language in all its details. There are many, many things there, right? Mixins and this and that. In due course of time, you'll pick all of that up. But to be productive in data science, what you need to learn are data science libraries, AI libraries, in particular NumPy, PyTorch, that we are going to use, TensorFlow, Keras. So because time is limited, we will focus our learning to the libraries rather than the language. And we will pick up that much of the language that we just need to be fluent with the libraries. And that part of the language is just these three things plus functions. And a little bit plus classes. That is, if you are reading my code, you may notice that they are in classes. But the way I write classes is so simple. In another session, I'll explain the functions. And so this is our session 2. Functions in this session number 2 in Python we'll do. So today we'll limit ourselves to statements, conditionals, and iteration. Right? This is it. Because if you can pick this up, you can in principle do anything you want with the language. Solve any problem you want with that language, with that syntax. Are we together, guys? So that is a long preamble. Let's now go back to our Jupyter notebook and actually do things.
So Asif, just to clarify on the classes, so you're sort of viewing it as like, hey, I need to have some class structure, but that's it, not really the true object oriented. You're not trying to get there.
We won't go there. We will use very light object orientedness. The only thing we'll use is in this particular workshop series, almost all the way to the end, we will subclass the base neural network. And think of it, if you don't want to learn about classes and objects, just think of it as a ritual, a style of coding you have to follow, right? Then at some
Correct.
point in another session, I will, of course, introduce what classes are, but we don't use that. See, object-oriented programming has an interesting history. It was much loved and much hated over the years. When it came about, people were absolutely in love with it. It started out as from C language, there was C, then there was C with classes, and then there was a beautiful language called Smalltalk, if I remember right. There are a lot of other things, but I'm giving you the big high points or the highlights. Smalltalk was a lovely language that popularized structured ways of writing object-oriented code. Java was deeply influenced by Smalltalk, and of course, its roots are in C++. Object-oriented languages became very popular for a long time. Then came the barbarians who started abusing it, as semi-literate people adopted Java, and they used it or misused it for a whole lot of messy code that they were creating. It's object-oriented programming got a lot of bad rap. So as always they say, right, don't blame something good by the practitioners of it, by looking at the faults of the practitioners. So that was certainly true with object-oriented programming. It was a lot of people overdid and abused it and wrote verbose code. So where do we stand today? There was a reaction against object-oriented programming. Then came functional programming and functional programming syntax. So today, the state of the art is use object-oriented functional code. Functional programming code. That is the state of the art. And Ramki, you were there in my big data class. You remember? We did almost everything using functional style within the object-oriented framework.
That's correct. Yes.
And that is the state of the art. So we'll get there gradually. But as they say, Rome wasn't built in a day. We'll gradually pick it up. Huh? But today, today we'll just focus on one thing. Let me know, guys, when you see my notebook.
So, Asif, any good books on Python?
There are many good books. See, guys, Python is not a language that you need books to learn. Go to the online site, and the best way to learn Python is by doing Python. Okay. Get started. Use books as references. There's nothing very profound about this language. Right? The beauty of Python is that it's so simple, so easy to get started, especially from a data science perspective, because we use only a limited part of Python, and that part is easy to start in a few hours. So why bother reading books? You know, there are a lot of Udemy courses or Coursera courses on Python. One of the popular ones is called Python for Everyone or Python for Everybody in Coursera. You can take that, you'll spend the better part of 4, 5, 6 weeks just learning Python. And you have to ask yourself, really, does it take that long, or it just takes a few hours to pick up? Okay. Because the goal is to do AI, not to become a guru of Python.
Okay, thank you, Asif.
So that is that. So let's repeat what we just did. I will create a new cell here and say, let's do that. X is equal to, what did I say? 17. Y is equal to 34. By the way, I'll upload all of these notebooks. What have we done here? Take 17 and put it in a box named X, right? So assignment statement. So this is called assignment statements. This is the way to read. So guys, always read from right to left. Likewise, can you interpret the second sentence? You can interpret. Now, how do we interpret Z is equal to X plus Y? Sorry, X plus Y. So how would we interpret that? We would say take the value of X, load X, take X and Y, and first we read from left to right. Take Y and add it to X, and actually don't add it to X, and take X and add the 2. Then store the results in a box named Z. Does this statement make sense, guys? This is how we should read it essentially. Is this looking simple, guys? What we taught? So far, so good. Now, what else can we do? Suppose now let's go to a loop or conditional. Suppose I say conditional branching. We can say if X is greater than, let's say 15, then do something. So one of the common things you do is you print things to the output. You say the print the value of X is greater than 15. So when we run this statement, what do you expect to happen? You know, whatever you wrote here gets printed out. And we just got introduced to something new. It's called a function. At this moment, take it for granted what this function is. We'll do more of it. But think of functions as commands. Whenever you see them opening with this curly bracket and ending with a curly bracket, you should know that it is a function. And functions are commands. You're asking the machine to do something. Are we together? Here it did something. That is an example of conditional. On the other hand, is why, if I had to say, if X is greater than 20, print greater than 20. So what do you think will happen when we run this sentence? Nothing, because the value, it won't act. It says execute this command only if the value of X is greater than 20, isn't it? It won't do that. But suppose we change this sentence to this. We put a else also here, the branching part of it. We say else what? Print the value of X is less than or equal to 20. So now what will happen? Let's run this. So far, does it make sense, guys? Any feedback? I want it from those of you who are just picking up Python. Does this look simple?
Yes, Asif.
Yeah. So one thing you will notice that I put some space here. When I used if you look at it, the X, Y, and Z are column aligned, right? They start at the beginning of this, the left margin. But do you notice, and this if also started like that, but do you notice that there's some blank space before this? So Python actually uses this indentation to understand that this sentence should be done only if this condition is true. So see what happens if this print statement is here, and I'll put another print statement here. Print hello world. Now let's see what happens when I run this. I ran this. What happened? This statement got printed. Why? Because if this condition is true, this part is dependent on this. This indented part is dependent on this. But the part that is not indented is an independent part. It's almost like it is one line apart. It's just think of it like this, right? But I can make it dependent. If I add indentation, right, then it will become dependent on this. Are we together? So let me just say, if X is greater than 15, now what will happen? The value of, so let me make it the other way around. Then it is much more illustrative. Home. If I run this, do you notice that the word hello world is printed, even though X is not less than 15? Why did it get printed? Because only this part is bound by this conditional. This is independent of it and it doesn't get bound. But if I add an indentation to it, do you notice I added a space to it? Then suddenly this part too depends on it. Nothing comes out. Why? Because everything that is indented is hostage to or bound by this part here that is unindented, the conditional. This conditional has to be true for these things to be done. Now, this is a surprise. People coming from C, C++, Java, etc. Indentation is never an important part of the syntax. You use semicolon at the end of the sentence, and indentation you do for cleanliness of the readability of the code, not for any other reason. But in Python, indentation is part of the structure. In C, for example, let me write the equivalent C, C++, Java code. C, C++, Java code. By the way, you notice that I'm starting things with hash marks. Anything with hash mark means the computer will ignore it. It's meant for human readability. It's a comment, in other words. Right? People say it is a comment. Comment means it's a commentary. The word comment comes from commentary. It's a commentary on the code written for some other human being to read. Are we together?
So Asif, there's no brackets to say that this is part of that if statement?
Yes, exactly. So if it was C, C++, Java, you would do this. If it is then, and here, whether you indented or did not indent would not matter. It simply wouldn't matter even if you wrote it like this. This would not look very clean. Your code review may not look so good, but this is still valid C++ Java syntax, isn't it? In other words, indentation doesn't matter except for code hygiene. But if you compare this with this, you notice that there are some things. It's more cluttered with this. There's more syntactic clutter, right? And so in Python, the brevity is emphasized. People believe, every culture has certain beliefs, whether those beliefs are true or not. So the belief of the Python culture, the Pythonic way they say, is that this is bad. The way this is written is bad. The way they write it is good because there is no syntactic clutter. If the code is more readable. Right? I'll leave it to you to decide whether that's true. By the way, nothing prevents you from doing it. By the way, if it is in Python, Java, you would C++, you would also put semicolons here. Right? What happens here, let us say, so I'll just comment this out or just divide it into another cell. Split cells. So look at this code. What if I did this? Will it work? Let's find out. This is more C, C++ Java-ish, right? What happens if after that, I also did this? Now this code, I hope, begins to look very much like C, C++ Java code, right? What if I did this and I put everything here also? You would realize that invalid syntax, the value fx is greater than, okay. It doesn't, this one doesn't seem to like it.
The only thing, Asif, I think there's a colon at the end of if, I think. Maybe that's the problem.
Yes. So
there is a colon at the end of
if.
Like in.
Yeah. Invalid, so it's not liking the semicolon. So we'll have to remove the semicolon here. Right? Print this, print that. So what happens is that this is very interesting. This is not going to let you do that. You can see that some things begin to bail out on you. So we'll remove this. Then you notice, I'm trying to make it look as C-like as possible. Let's try our luck with this now. Right? It went through. So a lot of people who transition from C, C++, what they do is they write their code in C, C++, Java, and then they start erasing things. So for example, if I took this code, so let's do that. I erase the semicolons, went fine. That is good.
Yeah.
Then I went up and I removed this curly brackets. That also looks fine. And then I put this. Well, that is good. That will work. And then I can remove this and it would work, right? And then I have to remember that, well, it won't work till I indent it. So there is a process you can go through to convert your C++ Java code, C++ Java code to Python code. And I've seen quite a few people do it. Actually, I must remember that I myself did it many, many years ago, moving to Python from C++ Java category. I would just write it in my code, Java code, and then go erase things from it. And it would become Python code. If that is any use, do that. Right? You can do that and it will work. Right? So that is something for you to remember. So anyway, so I'll remove this syntactic clutter. I'll keep it. Yeah. And should I keep this Java part? I'll remove.
Able to try these? Oh, yeah.
Likewise. Now, so this is for conditionals and branching. Actually, I should split it here. Cell here and make it a heading. Let's talk about the last thing now for today, which would be which would be iteration. How would we do that? Let us do a simple thing. We want to iterate over something, print hello 10 times, let us say. So what you would do is, and then just for like, you could say like this, for I in. So there are two ways of doing it. Actually, let me do the simplest statement. You could say I is equal to 1 or 0. Then you could say while I is less than 10, do whatever you want to do. Here, I'll say hello. By the way, in Python, whether you use a single quote or double quote doesn't matter. So you notice that I'm starting with single quote. I have to end with single quote, or I can use double quotes. Both of them are treated equivalently, right? You can also use triple quotes if you really want to, but be consistent. Whatever you start with, end with that. Are we together? Now, and I'll talk about the differences between triple quote versus double quote versus single quote in a moment. Double quote and single quote are perfectly okay, but this gives you some advantage. Hello, a fine day. Notice something interesting. This worked because I started with single quote. So till I hit the end quote, a double quote will not be treated as a special character. This is something important to remember. But on the other hand, I can do the other way around also. I have to do double quote, single quote, double quote. This, oh, by the way, this is continuing to run because I forgot to do I plus I is equal to, you have to increase the value of I by 1, right? You must increase the value of I by something. So now if I run this, it will print it only 10 times. So what did I do? What does this statement do? You take 1 and add it to the current value of I and put it back in the I box. So what will happen if I was 4, it will now become 5. And so you keep on testing whether I is less than 10. Eventually, I will become bigger than 10 because at each cycle, each loop, it is increasing by 1. Increasing by 1, and so eventually this loop will break. That's the word people use. Now you notice that I could get away with it. I used double quotes and this happened. So talking about this quotes business or the strings business, let me mention something. Python has one very nice thing. Suppose you, and this will be good for you, some of you. Suppose I have a statement, a message. You can actually do three quotes. And when you do 3 quotes, you can say, and so forth. When I run this, when I try to print this, see what happens. Print message. What do you notice here? It preserves your multi-line syntax, isn't it, guys? So if you were doing it in C, C++, Java, what you would be doing is you would be putting a \n. Do you remember that? Those of you who are familiar with those languages, you would be putting special characters to break line. In Python, you don't have to do that. You just can print that. By the way, now in Java also, you don't have to do that. Java now fully supports this multi-line syntax, almost identically.
So how did you achieve that? Lost you there, Asif?
Just started with 3 quotes, not 2. Do you notice that there are 3 double quotes?
Yes.
When you start with 3 double quotes, whatever you put here can be multi-line, and it will preserve the line breaks.
Okay, perfect. Okay.
That is that. Huh? So this is about, so let me give it a topic heading.
Sorry, it's just to revise the rules, like single or double quote is still across a single line. It doesn't matter, single or double quote. You can choose what we want. Okay.
You have to give explicit line breaks.
Okay. Okay.
So does it support backticks, Asif?
Does it? No, backticks, I don't think it supports. Try it out. I've never used it.
Okay. We use it a lot in JavaScript, the backticks.
Yeah, I don't think I have. In Python, I have seen that very commonly. So this was an aside. Now,
what is the quick magic you did to highlight it in Jupyter Notebook? You just did something? What is that?
oh,
You suddenly just became a...
Yeah, okay. So here is what I do. So suppose you want to create a text heading. 2 hash marks is a subheading. So suppose I say, and finally we conclude. We learned the following start assignment state. Learned whatever iteration conditionals, right? And iterations, loops. So this is, you want it to be understood as text. I wrote it in the markup language. What I do is escape M and then control enter. Right? So
I see.
Yeah, so there are a lot of the keyword shortcuts. Gradually, you'll develop muscle memory. So you'll become very, very efficient with Jupyter Notebooks. It has a lot of keyboard accelerators. You can go here. Do you see the keyboard shortcuts?
Got it.
You can use it and become familiar with it. See, you can't learn all of it in one day, right? But what I would suggest is start with some common ones. Let's say that start with these, pick 2, 3 every month, pick 1 or 2 and become familiar with it. Soon you'll develop muscle memory about all this, because it's such a long list. You can't just suddenly do everything in one go.
So Asif, is there any reason why you kind of split up into these boxes? Is it because you want to do it that way, or?
Yeah, so these boxes are called cells.
Okay.
This is a cell, this is a cell. So notebook, a Jupyter notebook is a collection of cells. The cells could be of one of 2 types, either code or markdown. Forget about the raw NB and headings and all that. Huh? Either code means it's a Jupyter, it's your Python code. Right? Okay. Actually, the word Jupyter comes by putting 3 languages together. Can you guess what those 3 languages are?
Julia.
Great.
Python, R.
Yes, exactly. The word Jupyter. So let me just mention that. Jupyter, the word Jupyter comes from, that is why it's misspelled like that. Jupyter, sorry, Julia, Python, and R. That's where it comes from, Jupyter. So, so guys, for iteration, I would like to teach you more. There is a for loop. So what have we missed and what we should have covered, but we'll do it in the next session. Today, we have been going on for 3.5 hours now for the next time. So again, this is escape pen. This is for the next time. What are we going to do? We are going to do this. We are going to understand for loops. There's something beautiful that you don't see in other languages. You don't see in C, C++, Python. These are called comprehension, right? And generators. These are both, these are very elegant things. The for loop, of course, you'll become familiar with in no time, but because for loops and comprehensions and generators go together, I'll discuss it the next time as a separate topic. Huh? And list comprehensions and generators are absolutely marvelous as features of Python. I really like those. And we'll talk about it the next time.
Asif, this was actually really good, and glad that you also like sort of enforcing this the typing rule, right? So basically, type hint. It's actually really good. It makes it then like if you do that correctly, then it gets like to Java level or C++ level, you know, pretty much without any. I mean, provided you do it.
Absolutely. I talked about type hinting. So if you were to go back and read my code, let's say any one of them, transfer learning. Do you notice that I give the return value everywhere? Create, compose. I say what each thing is, classify, result is, okay. A list, do you notice that? I say that create labels will return you a list of strings. Wherever needed, like wherever there is a need to do that, I do that. If you go to the data set CIFAR, you will see me use this quite a bit. Target, you see this self-target. 1 second. So self is implicit.
Oh yeah. Wow.
You see the type hinting and the return value here.
Perfect. No, it's actually, I think it's a very important coding practice, like a secure coding, right? Like secure coding with Python. That's what you're getting at. Yeah.
It is one of the best practices that very few people practice.
I know. Yeah. I never knew this thing as it's always so much on Python 2.7. I knew some things, but I never knew this thing existed actually. So, yeah.
Right, it's important when you start out to start out the right way. So,
correct.
Okay, guys. So with that, I'll end today's session. It's almost 4 o'clock. I will open it up to questions. I'll stop sharing. And should I stop the recording, guys, before we have the questions?
Oh, yes, sir.
Okay, guys, now you can feel free to ask all your questions if you were hesitant to ask on recording. Was the session useful or was it too elementary?
That was very good, Asif.
Help you.
That's it's really good. Thank you so much. I'll drop off, Asif. Thank you.
Okay.
Yes, if this was helpful, but I think we need to get a little more into the actually using a few things to come back with some questions. Yeah.
Right. Another session or so, you'll know all the Python that is needed to learn in data science. There isn't that much. So I'll post this notebook to the class website, guys, today's. And all the recordings will be, at this moment, they are being live broadcast to YouTube. Actually, that is also something I should